So we just have to read off the graph here for the first bit now. One thing that's very important here is to show your work on the diagram above. So if you just have the right answer here, you won't get all of the marks, you get some of the marks. So we have to estimate how far he's travelled by 8 o'clock. So 8 o'clock is there, so if you draw a little line up there from 8 o'clock, so it's obviously going to be where it meets the graph there, and like you should really be drawing another line over there. You might not need to have the lines, if dots or whatever might get you the marks, but either way it's going to be about so it's a little bit more than 12, so I'll just say 13. I could say 14 either. I'll just say 13. So 13 kilometers. So that's just reading straight from the graph. Right, find his speed in kilometers per hour while he was travelling from A to B. Right, so A to B. So speed anyway is distance divided by time. So let's see how far he travelled from A to B. So the distance is up the side there, so it'll just be the full way up, so it'll be 32 kilometers. So he's travelled 32 kilometers. So that's the distance. And now let's get the time. So he's obviously started at 7 o'clock and he's gotten there at 9 o'clock. Oh, sorry, I'm looking at the wrong. Yeah, sorry, it's A to B, isn't it? So it's just from there up. So it's from 20 up to 32 is the distance. So it's just 12. And the time now, the time is from, well, he starts at A at 8:30 and he gets to he gets there at 9 o'clock, so it's going to be half an hour. Now, important thing to do here, if you put in 30 there, that's wrong because that's in minutes and they want it in kilometers per hour. So we have to change 30 minutes into hours. So it's half an hour. So you could put in 1/2 there, or you could put in 0.5 there. So whatever you want, either way you'll get 24 kilometers per hour. Then, so we have to use the information here to complete the graph. So he stopped at B for 30 minutes. So if he stopped at B for 30 minutes, that means the distance won't get any bigger, so the graph won't go up anymore. And it can't really anyway. So it's just going to go in a straight line. So that's the next bit there. So that's 30 minutes. That's from 9 o'clock until 9:30. Then he cycled the 32 kilometers back home at a constant speed. This took him 1 hour. So he travelled 32 kilometers in 1 hour. So 1 hour after 9:30 would get us to 10:30. So it has to be up there somewhere that our next point would be. And he's gone 32 kilometers back. And that's just the whole way home. So that's what the graph is going to look like. Right. Here then we're just going up in 1.5, so add on 1.5 and we get 9, then add on another 1.5 and we get 10.5. And then we get 12, and then we get 13.5. If Ellie continued in this pattern, find the distance she would run in week 100. So we could just keep going on and getting, so then 7 would be 15, and then 8 would be 16.5, and then 9 would be 18, and so on. We could keep going on until we get to what the 101 is. Or we could work it out with the nth term. So t to the n here would be, so we're using the formula a plus n minus 1d. And we want for the 100 term, so we're getting T100. A is the first term, which is 6. We put in the 100 for N. And our D here is 1.5. That's the difference. That's what it goes up by each time. And that gives us 154.5. Explain why Ellie cannot continue this pattern indefinitely. Right, so what's going on here is that she's running an extra 1.5 kilometers every week, obviously, so it's impossible for somebody to just do that forever. So somebody can't, at some stage it's going to be impossible for a human to run that far. So it will exceed the human limit. For distance ran in a week. Right, SN then is the total distance in kilometers run by Ellie after n weeks. So we have to write S of n in terms of n. So we just have to go to our log tables here. S of n is n over 2 2a plus n minus 1d. And let's just put in everything again then. A is still going to be what we started out with. It's the same as what we used up above. It's 6 and D is 1.5. S of n is equal to, so we don't have an n, we're just going to leave in n in the equation. Then 2 times 6 plus n minus 1 times 1.5. I could call that 3 over 2, it might be a bit easier to look at when we're dealing with this. We get that, and then we can simplify a bit further. If I multiply the n over 2 into everything, get that. Then using our part, find the total distance run by Ellie in kilometers after 10 weeks. Therefore we're just going to put in a 10 into what we got it there. So into this, that'll be 3 over 4 times 10 squared plus 21 over 4 times by 10. That'll give us 75 there. You can use calculator from here. And we get 127.5 kilometers. That's all then for question 8.